We're going to look at the concept of reductions, and what that means is to actually take a trig ratio and express it as a ratio of a positive acute angle. First, let's just take a quick look at how this works. If we have an angle, right, it has an x, a y, and an r value associated with it. If we have an angle in the second quadrant by that same amount off the horizontal axis, right? So in other words, 180 minus theta, we notice that we get exactly the same values for x, y, and r, which means that the ratios, all the ratios will have the same magnitude. Their sign might change. Likewise, if we go into the third quadrant, we get, so it's 180 plus theta, we get those same values again. And if we go into the fourth quadrant, we get those same values again. Right, so exact summary, if we come off a horizontal axis, ratio name doesn't change, and we get the sign from the cast diagram. Right, now we're going to look at a similar thing, but we are going to come off the vertical axis. So if we come back into the first quadrant by theta, in other words 90 minus theta, we notice that we get those same numbers, but that the x's and y's have swapped around. Right, and I'm going to show you in the second quadrant, if we go 90 plus theta, we get the same x and y values, but they've swapped around. Likewise, if we go into the third quadrant, we get those same values, 270 minus theta. And finally, if we go into the fourth quadrant, we get those same values. Right, so the upshot of this is that if you replace x and y in your ratios, then your ratio becomes the co-ratio. So sine would change to cosine. And cosine or cos would change to sine. Once again, we get the sine, S-I-G-N, from the cast diagram. Right, now let's dive into solving a problem. So I'm going to draw this just as a reminder, all sine, tan, cos. And what I'm going to try to do is I'm going to try and reduce each of these things. Now sine 353, we're in the fourth quadrant, and we are actually 7 degrees away from a horizontal axis. Right, but sine 353 is negative, so this will be negative sine 7 degrees. Notice I've come off the horizontal axis, 360 minus 7. Cos 240, I'm in quadrant 3, cos is negative in quadrant 3, and I'm 60 degrees away from a horizontal axis. Notice I'm choosing to use the horizontal axis each time. Cos 180, well, that's actually a special angle. I could get it directly from a calculator, but let's just think how we could do it without a calculator, right? And if we had 180 degrees, whatever my radius is, suppose my radius is 5, then this point here will be negative 5, 0. And cos is x over r. So in fact, the cos of 180 is actually just negative 1. Right, negative 1. The other way we can do that is if we can visualize a cos graph, we actually know that it bottoms out at negative 1 halfway through its life at 180. Okay, right. Tan 225, we're in quadrant 3 by 45 degrees, tan 45 degrees. Tan is positive in quadrant 3. Cos 97, now this is a bit strange because we don't know what cos of 97 is, but we do know that it's actually 7 degrees, and we've already got a 7. It's 7 degrees away from the horizontal axis. Sorry, from the vertical axis. Now remember that if I come off the vertical axis, I need to change to my co-ratio. Now the co-ratio of cos is sine. So this is going to be sine of 7 degrees, but just be careful because it's actually going to be negative sine of 7 degrees because cos is negative in quadrant 2. Right, now cos of 60, right, so there's a total of 4 negative signs in this thing, so it will be positive. The sine 7 degree can divide out on the numerator and on the denominator. They go in once each, right? And now it just boils down to some special angles, right? And again, at this point, we won't actually know whether you've used your calculator to determine that cos of 60 is actually a half and tan of 45 is 1. So final answer equals a half. One thing that you can certainly do is use your calculator, type all of this into your calculator, check that you've got it right. Right, this one, we can't use a calculator. We're still going to use this, all sine, tan, cos, right? Cos, sine 90 plus theta, we in the second quadrant, sine's positive in the second quadrant, but we've come off a vertical axis, so we changed the co-ratio of sine, cosine or cos theta. This one, cos of minus 270 minus theta, that's a bit tricky to work out where we are. I'm going to add 360 degrees, because remember, adding 360 takes you back to the same place in the Cartesian plane. So when I do that, I actually get cos of 90 minus theta. I haven't reduced it yet. I've just sort of made it a little bit simpler to work out what's going on. Cos of 180 plus theta, I'm in quadrant 3, and that's, sorry, off a horizontal axis, so that's negative cos theta. And cos of minus theta, I'm actually in quadrant 4. All right, if you're not sure about that, you could add 360, but basically we've gone 0 minus theta, which means we've gone in a clockwise direction. And cos is positive, so we're theta degrees away from a horizontal axis, so we get that. Right, straight away now we can divide out, not cancel, but divide cos theta, it goes in once, cos theta, it goes in once. Cos of 90 minus theta, that is in quadrant 1 off a vertical axis, and because I've come off a vertical axis, I must change the co-ratio of cosine, which is sine. So that just becomes sine theta. On the denominator, I've got negative cos theta, and a trig identity is that sine over cos is tan, so final answer here, negative tan theta. Okay, I hope you found that useful.